Today's lesson is on factoring higher degree polynomials. So we'll be looking at cubics and up. And this is the third time that we visited factoring. So I do assume that you know how to do diamonds with trinomials and difference of squares and GCFs and things like that. Today's lesson is pretty juicy, so don't forget to pause so you can write down stuff and pause so you can try different problems. Juicy. That's a wonderful word. Anyway, is 3 a factor of 6? If so, why? I would definitely say yes, that 3 is a factor of 6. And here's a quick way you can test whether something is a factor. If you divide it in and the remainder is 0, that means it's a factor. Okay, that's just a quick way to test to see if something is a factor. We also say that if it goes in evenly, or the genuine definition is if you can find another number to multiply by that'll give you that number, then it's a factor. In fact, they're both factors. And there's different ways to factor numbers. We could do prime factorizations and so forth and so on. But today, we're going to be looking at factors of polynomials. So, if I arbitrarily give you x plus 1 and ask you, is it a factor of this polynomial? One way that you could quickly test that is to use synthetic division. You could use long division, but synthetic's faster. And check to see if the remainder is 0. So if this is our divisor, -1, and don't forget, we're going to go here and grab our coefficients all the way down the line. Make sure there's no missing powers, 3, 2, 1, none. If there are missing powers, don't forget your zeros. So bring the first one down, multiply, add, multiply, add, multiply. That is not 0. Not 0. Therefore, x plus 1 is not a factor of this polynomial. Okay. Now, here's time for the bad news. Often, the only method is guess and check. And you're just looking for 0 remainder. So you just keep trying different things until you get a 0 remainder. And this is one of many methods. So when I say guess and check, guess what? We know how to check it. We want to see if we get the 0 remainder, but how do you know what to guess? Because there are infinitely many numbers in the world, and they could be real, imaginary, irrational, and everything. But here's one way to narrow down the selection choice, and it's called the rational roots theorem. I like to call it the possible rational roots theorem because it tells you the possible things to use and check with your synthetic division. So what you do is you look at your polynomial and you want to focus on the leading coefficient and the constant term only. Now, when we say rational, do you remember that means numbers that can be written over a and b, where a and b are integers? So pretty much we're just looking for the fraction answers, the whole numbers, the integers, we're looking for these. These are what we mean by rational numbers. Okay. This theorem will not find imaginary numbers, nor will it find those odd radical numbers, like the square root of 11 or something like that. It won't help with those. So what you do is you take the factors of the constant term and put them over the factors of the leading coefficient. Let's see how this works. So find the possible, didn't ask you to factor, just the possible rational roots. So we're going to take the constant term and the leading coefficient. So I want the factors of 9 over the factors of 2. And I want plus or minus on both of those. So I'm looking at the factors of 9. That would be 1, 3, and 9. Those are the numbers that go in evenly. And over the factors of 2. Okay? So now I want every possible combination of those two. So that would be 1 over 1, 3 over 1, 9 over 1, which is just 9. And then we do all of these numbers over 2. So 1 over 2, 3 over 2, and 9 over 2. Sometimes the numbers will repeat and you want to simplify your list a little bit. But here we got lucky. None of these repeated. So this means we have 1, 2, 3, 4, 5, 6, 12 possible rational roots. Why do I say 12? Because they could be positive or negative. 12 possible rational roots. Okay. So now, once we have the possibles, let's go ahead and see how we can factor these polynomials. The first thing I want to say to you is that we don't want to forget all of our other strategies, because some of our other strategies are really easy and we're good at them. So still, I'm looking for the GCF first. There's no GCF. 4 terms, so I'm definitely going to try to factor by grouping. X squared comes out. I have x plus 2. Negative comes out, and I have 5x minus 6. And I say, oh, no, these don't match. So I know factor by grouping did not work. Okay, so now I'm going to have to try something else. And that something else is the guess and check method. So I immediately zoom in on the 6 and the 1. So my possibles, I always look for my possibles because it saves me lots of time. I have the factors of 6 over the factors of 1. I love it when the leading coefficient is 1. Okay, that cuts the work way down. So the factors of 6 are 1, 2, 3, and 6. And the factors of 1 is just 1. So pretty much out of all the numbers in this whole world, I've now limited the things I have to check down to 8 possibilities. And that's great news. So I always start with 1 because 1 works a lot. I've noticed that. So I'm just going to put 1 over here, and I'm going to check, put my coefficients, 1, 2, -5, -6, straight down, multiply, add, multiply, and I can see already it's not working. That did not work. No need of trying to keep erasing. You'll just tear your paper up. Just make sure you have plenty of scratch paper. And you could do it right in your notes. Just put a nice little neat X on it and keep it moving. The next thing I'm going to try is -1. 1, 2, same coefficients. I used to watch my aunt do her homework when I was a little girl. And her problems would take up the whole page. And I say, wow, I want to do math like that. And it took a while, but man, sometimes these will take the whole page. So I'm going to go down, -1, 1, -1, -6. Yay! I'm so happy when I get that. Yay. Okay, so how do we interpret this and how do we move forward is the question. So what's going on is if -1 is in the corner, think back to the last lesson, then the divisor must have been x plus 1. Okay, and now once we get down to 3 numbers, well, think back to when you did synthetic division in the last lesson, that's a 3. So that means I'm going to drop down to the second power, and these are my coefficients. Okay, and I'm not completely factored yet, but quadratics, I'm amazing at quadratics. I'm going to try a diamond and cross my fingers. So 3 and 2, negative on the 2. And now, done. And just like it is in the diamond, those are my direct factors. You don't change the sign or anything. So you see, there's the +3, there's the -2. But when you come from this box, you do have to go opposite. Okay, this one's important. And here's our factors. Alrighty. So we use guess and check to factor this polynomial. Alrighty, let's move forward and try another one because there's different little things that can come up, and I just want to show you a few different situations that you might see. Okay, no GCF. Oh, yes, there is a GCF. And I noticed there's no constant term, so that's a big hint. I'm going to factor x out. There's an x all the way across, and so I have x to the 4th power minus x cubed minus 9x squared minus 11x minus 4. And now, don't forget about that x. You can factor it out, but it's not gone anywhere. It's not gone anywhere at all. I do want you to notice, though, that our leading coefficient is 1 and our constant term is -4. But we only need the 4 because it's going to be plus and minus anyway. So now what I'm going to do is I'm going to look at my possibles. That's always the first thing I look at. So I got the factors of 4, which are 1, 2, and 4 over the factors of 1. And remember, when it's 1, you don't even have to worry about it. So my possibles are plus or minus 1, 2, and 4. So now I'm going to start my guess and check process with the synthetic division. I always like to start with 1. And now look inside here for your coefficients. 4, 3, 2, 1. Okay, I don't need any zeros. I got a 1, a -1, -9, -11, and -4. Remember, we just take those coefficients and put them right on in there like we did in the last lesson when we learned synthetic division. So now, I'm going to bring that down and start multiplying. I can see already it's not going to work. Okay, no, okay. The ones that don't work, you want to cross it out because you don't want to get confused and think it worked or something. So now I'm going to try -1 and keep my fingers crossed. And make sure you space out and write neatly so that you can read your own writing. And while you want to move swiftly because you like to get stuff done, be careful because one mistake can cost you a lot of time. Can cost you a lot of time. Yay, happy face. Okay, anyway, I got my 0. Yes. But I still have 4 terms. So I want to keep going. Okay? I want to keep going. Always, and this is big. As a matter of fact, let me make this another color. Just that's how important it is. Always try the same number again. If it works. If you get a 0, you want to try the same number again. And we don't even have to rewrite everything. We can kind of use the leftovers right here. We don't even have to start fresh and rewrite it. I'm going to use this, try the same thing. Sometimes it works again, sometimes it doesn't. But you do have repeats, and I notice often I'll have repeats. Just like now, that repeats. Okay, so I got a 0 again. Now, here's what I want you to notice. Once you get down, let me get my pretty pink again. Once you get down to 3 terms, that's a quadratic. Okay, 3 terms is a quadratic. And you can see you have your constant term, your x term, and your x squared term. So let's see what all we have because we're almost done. We just need to interpret this. This is an x plus 1. This is another x plus 1. And this right here is x squared minus 3x minus 4. It's a quadratic, and I'm a quadratic specialist. So I'm going to try my diamond, cross my fingers. I need 2 numbers that multiply to 4, but add to -3. So I'm going to make the big one negative. Okay, so I'm just bringing this down. And I have all my x's down to the first power. I have 4 factors here. Oh, guess what I nearly forgot? Oh my goodness. It's a good thing I always check. Is this x? And notice this tells me I should have 5 x's. So in my final problem, there should definitely be that x that we factored out. And I always go back and check my number of x's. So that's 1, 2, 3, 4, 5 x's. And we started with 5th degree. So I should have 5. Okay, let's do one last example. Just so we can get some more practice. Okay, there's no GCF. My possibles, that's where I want to start. So that would be, oh good, and my leading coefficient is still 1. So the factors of 20, let's see, that's 1, 2, not 3, but 4, 5, not 6, 7, 8, 9, 10 works, and 20. 1 times 20, 2 times 10, 4 times 5. Yeah, I think that's it, and they're all over 1. So those are my possibles. Now I'm going to start. Have my coefficients should be 1, 0, -20, +20, -21, and 20. So I'm going to check my 1 again. -19, -19, 1, 1, -20. Oh, thank goodness that worked. And I just wanted to give you a feel of how this process really goes. Okay, I'm going to tell you already that 1's not going to work again. 2's not going to work. Negative 2's not going to work. Already tried them. But I tell you what will work is 4. But you would have to do guess and check on your own to see what actually works. And there we have it. And at this point, whenever you see a little pattern like this, that's a clue that factor by grouping will work. So that's something else you could do. But I could continue on and see what else would work. I would try 4 again. 5, negative 5. You could keep going. And I'm just going to tell you negative 5 does work because I already tried it. And at this point, once you get your 3 terms, we know we're down to a quadratic. But let's look at what all we have. And I think I'm going to change colors here. I have a x minus 1. Remember opposite. I have a x minus 4. I have a x plus 5. And I also have this. And this is x squared, no x term, plus 1. And now we remember from the last lesson how to factor that. X plus I, x minus I. Whenever there's a sum of squares, that's when we have to use the imaginary. Okay. And that's, let me double check. 1, 2, 3, 4, 5. Started with the 5th power, so I feel pretty good about that.